Let me welcome you, lovely one, once again to the Aplus lesson learning platform. My name is Anthony Osei Mensah, popularly referred to as Sir Tony, the mathematics doctor. In this lesson, we will consider the topic indices. The first question I want to take a look at, read simplify 3 raised to the power a minus 1 multiplied by 27 raised to the power a plus 1, all divided by 81. Let us begin. Now, my first question is, why is this indices, or why is this question indices? It is simple. Indices questions are part of mathematics questions that come with powers. So if you check this question, we have a base 3, and then there's a power a minus 1. The same thing, base 27, the power a plus 1, base 81 with the power a. Technically, it is not only indices questions and the mathematical topics that has the powers, but something makes this indices. If we see in between the first bases, or let's say in between the first base and then the second base, we can see a multiplication sign. So base 3 power a minus 1 is joined by the base 27 raised to the power a plus 1 using the multiplication sign. So because multiplication sign is in between these two bases, or this indicial questions, or this indices questions up there, or indices numbers, let me put it that way. Because the indices numbers have a multiplication sign separating them, then we can approach that understanding that this is indices. Now, one thing I also saw is the division sign separates the numerator of the question from the denominator. And the numerators are made of base and power. So the denominator is also made up of a base and a power. So the multiplication sign and the division sign has now given me the edge to know that this question can be solved with the indices approach. So finally, we can conclude that this question is an indices question. Let me repeat that again. I can see exponent or powers on their basis, and I can also see a multiplication and a division sign. That makes it indices. Now, let me clarify this. Other questions can come with the addition and the subtraction, separating them. They will still be indices. When we get there, I'll explain how to use indices approach to solve. Now, let's get into the method or the methodology for this particular question. Once you conclude or you know that the question is under indices, ask yourself this question before you begin. Does this question contain an equal sign, or it doesn't contain an equal sign? That is to say, is this an indices question with equal sign or an indices question without equal sign? The answer is so clear. This indices question has no equal sign. So we have to solve it using the laws of indices and then the properties of indices, if there are any. To begin with, the basis of the indices question will be our first target for the steps. This is base 3, base 27, base 81. The bases are different. And with indices, to apply the laws, the first condition is to make the bases the same. So if you check the base 3, we can maintain it and change 27 also to base 3 because it is possible. We can also change 81 to base 3. So in place of 27 as a base, we will replace base 27 with 3 raised to the power 3. So that the base will change to 3 and another power. So in place of 27, we'll put 3 raised to the power 3. Now 81 can also be converted in terms of 3. That is, we change base 81 to 3. And base 81 can be changed into 3 raised to the power 4. Now let's do the substitution. At this point, we will then substitute all the bases that we've converted into 3 into their base 3 with the powers. This is what I mean. You come to the next step. So with the next step, we will draw our division line. Then we'll concentrate on the numerator, or concentrate on the bases at the numerator. We have base 3 raised to the power a minus 1. We have maintained base 3 raised to the power a minus 1 because it is base 3. Then we bring the multiplication sign. Then we take 27. Don't forget that 27 is not in base 3. So we have to go to the conversion. Then take the base 3 that was belonging, or that is belonging to the 27. And that is base 3 power 3. So in place of 27 alone, you put base 3 power 3. Because base 3 power 3 or 3 power 3 is 27. But there is something you have to also note. There is an original power, or the first power of the 27 is a plus 1. And now it has been converted to bring a new power 3. So what we have to do is these two powers must be multiplied. And that is according to the third law of indices. That says that if there are two or more powers, you multiply them. So the power 3 here that came in this step will multiply the power a plus 1. So it will be into bracket a plus 1. I'll use the multiplication sign as the bracket. So it will be 3 times a plus 1. And that is what I've done here. 3 times a plus 1. So note that 3 as the base, the power 3 here. So 3 power 3 is 27. Then the power a plus 1 is still there. We do the same thing to the denominator. And the denominator is 81. And we don't need 81 as a base. We need 3. So we converted 81 into 3 power 4. So we substitute 3 power 4 in place of 81. So it becomes 3 power 4. Please don't forget that 3 power 4 alone, 3 power 4 is standing in place of 81. So we are left with the power from the beginning, that is A. So if a new power 4 is there and there's an old power A, the old power and the new power will multiply. So it will be 4 times the A. So we will take off the bracket in this particular method. So we go to the next step. Then this has no bracket, so we have to repeat 3 raised to the power a minus 1 multiplied by or times 3 raised to the power. The power will open up. So the bracket must open. So we use 3 to multiply a, making it 3a. Then 3 will multiply the positive 1, making it positive 3. Then we will do the same thing to the denominator. We have 3 raised to the power 4 into bracket a. 4 into bracket a means 4 times a. So we get 4a. Now we continue with the law because the bases are all the same. So we've accomplished same basis. Now the laws of indices can be applied nicely. I want to concentrate on the numerator. And when I check the numerator of this particular step, I realized that the bases are the same, and then the only operational sign separating the two indices numbers will be the multiplication sign at the numerator. So if I want to continue, I will just have to represent the two indices numbers with one base, same basis. So I'll repeat one base. Don't take the two bases. And that is how the law works. I'll use the first law of indices that I refer to as the multiplication law. Since I see a multiplication sign, I will repeat one of the base provided the bases are the same. Then I will go ahead and add the powers because of the multiplication sign. So let me add the powers. The first power is a minus 1. I will add it to the next power is 3a plus 3. Let me repeat the denominator because I'm not using it in the procedure now. So 3 raised to the power 4a. Now let's proceed to simplify the powers at the numerator level. So at the numerator level, we simplify the powers at this part of my solution or my method. Still base 3. There is one thing that you have to know, that the base 3 will continue in the process or in the solution until we are sure the base 3 with the power can be converted into a whole number. Until then, please always bring your base because there cannot be a power in mathematics without a base. So base 3. Now the powers can be grouped in terms of like terms because we have letters or unknowns in the form of a. And we have constants in the form of -1 and 3. So group like terms. So I have a. And I can see positive 3a. That is plus 3a or 3a. So you group them. I'm done with the letters. So a and 3a has been grouped. Continue or proceed with the constant. If you want to start with a -1, fine. If you want to start with a positive 3, fine. Choose your own choice. In my case, I'll start with positive 3. So plus 3, which is a constant number. And -1, which is also a constant number. So -1. Then repeat your denominator, 3 raised to the power 4a. We continue the solution. Now, we simplify the numerator as usual. Bring the base. The numerator will be simplified. A plus 3a will give us 4a at the power level. Then 3 minus 1 will give us 2, so positive 2. So that is at the power level. Then we bring the denominator to as 3 raised to the power 4a. Remember, they are dividing. That is to say, let me put this step there for you to know how it looks like. 3 raised to the power 4a plus 2 is divided by 3 raised to the power 4a. So in another way of writing this, or in another way of writing it, it can be 3 raised to the power 4a plus 2 divided by 3 raised to the power 4a. So remember, this one here and this one here are the same. So it shows clearly the division effect here. So Indices second law, or the Indices division law, states that provided the bases are the same for the indices numbers and there is a division sign, just repeat one of the base and subtract the powers. So base 3, I repeat 1, then I subtract the powers. The powers are 4a plus 2. Then minus subtraction because of the division sign, 4a, and that is a law. It says that when the bases are the same and then you have a division sign, just repeat one base, take the 2 powers and subtract them because of the division sign. So as you can see, I've subtracted the 2 powers. Now simplify. I have 3 raised to the power 4a. There are letters called 4a minus 4a. So group like terms. So 4a minus 4a becomes the unknown. Then plus the constant 2 at the power level. So 4a minus 4a is 0. That is nothing. So it remains with the constant 2. So you write 3 raised to the power 2. And then you all know that 3 raised to the power 2, even though it is in the power or the index or the exponential form, that is indices. But you can also convert it to a whole number. So 3 raised to the power 2 is 9. So we can finalize our answer as 9. So it means that the entire question given from the beginning can be simplified into the single number or the whole number 9. So the final answer for this question is 9. Lovely one, don't forget that this is a systematic approach to solve this question. I categorically took my time to solve it step by step. So you can also go through this, understand it well, and make the steps more easier for yourself by even reducing it. I have a lot of questions in the next video. Please go there and watch the videos. And if you have any question, don't forget to drop your comments and then contact us for more information and more answers. Thank you very much. This is Sir Tony, the mathematics doctor. I'll see you in the next video. God bless you.